which is heavier testers. So that's a good scenario to have. The wrong reason to have 1:1 is I don't have automation. Maybe that's where you start with, but that's not a future-proof ratio. 8:1. Typically in this case, I call it technology service because what you may find is in some cases the automation is very heavy. Second is you may find a scenario where along with it being a very high ratio, it's a service which you're providing which already has different other ways and means of it being tested. In some cases you may even have, I think the earlier person talked to your system. What is the performance testing framework that you're supposed to use for that? What is the UI automation framework you're supposed to use for that? What is something else you're supposed to use for that? Sometimes those technologies do not allow you to readily get skills to get that done. Not talking about manual testing. Imagine if you even needed to do automation with that. Sometimes it's a force fit. You don't have skill, thus you have to manage. That could be a case where you do more manual testing, but then you essentially try to build skill or find skill. And if you look across the spectrum, it would go from somewhere between low to medium in terms of specializations. Again, that's another case where a high dev test ratio might actually be useful. Scrum team locations. Typically, I found that when you have zero testers, it's a smaller team, it's co-located. Distributed works can work if you have like higher numbers because there's enough mass. But as the ratios become smaller, imagine this 10:1 scenario where the poor tester is sitting in a different time zone and the 10 developers sitting in a different time zone. Why do people hire us? Let me ask a question. When you go to a job, what is one of the primary things they hire you for? Any questions?
Talent.
Sorry? Talent. Okay. How do you make a difference? Okay.
Deliver value.
How do you deliver value? What else?
Quick replacement of the previous guy who is working.
Quick replacement of the previous guy. So fundamentally, broadly, if you look, one of the reasons they hire you for is, and all of these are right, is your ability to learn and your ability to be relevant in the context that you're going into. Skill is one of them, learnability is another one of them. What I would like to bring out to you is that all of you just told me that based on type of work, these ratios can change. Imagine in your organization itself, there are different types of work going on. You need to make sure that you're ready with the kind of skill that you have to be able to move across each one of these scenarios. Typically, these scenarios will require different ratios. In some cases, that's what I call as fungibility, which means how do you move across from one to the other. Typically, the developer I had in the 8:1, the tester I had in the 8:1 ratio was almost a developer. And his skill levels were equivalent. Which is why I asked you the question saying, do your testers code? Or can they code? And I'm sure they can. But then if you aren't asking them to code, if you aren't asking them to write automation scripts, if you aren't asking them to build simulators, if you aren't asking them to write possibly tools, are you really using them well enough? There's a question each of you should ask yourself if you're in that shoe, or ask of yourself as a leader if that's what you're doing. Are you building your team right? Or are you making yourself ready for the desire for you to work across all these types of projects or products is what I would say. Nature of deployment. Sometimes based on nature of deployment, like I said, your ratios would change. AD buckets are good cases where you possibly launch both and try to see what works, what doesn't. Sometimes you do crowdsource testing, some kind of a thing like that, which allows you to do some of things like dark launches are a very good example. We've used dark launches in one of my prior companies. We do use feature toggles too. So I like that slide, pretty nice one. So if you release in buckets, typically your higher ratios when you go ahead and release in buckets. When you have obviously a bigger ratio, I think someone brought up the quality angle. High automation, you might want to be more careful, use more toggles, use more controls, so you can possibly do things, have more automation in picture. release in smaller increments which you could roll on and roll off as you need. That's another way to look at it. Now, here's more into the solution. Sometimes I tell you, yeah, I'm going to quote Shakespeare, and I'm making this up as I speak. Some ratios are right. Some teams have ratios thrust upon them. If you heard Macbeth, there's a quote about some men are great, some achieve greatness, and some have greatness thrust upon them. This is, I think, one of Shakespeare's quotes. Sometimes ratios are not what you choose; they are thrust upon. So I'm hoping the other message you're taking back from this is, when things change, you know how to adapt. So you could use A/B buckets if you thrust that ratio on. You could use scenarios like similar increments. Typically, when you have more ratios, you can be a lot more defined and try to do it, because it requires you to do a lot of. If I have to test 82 devices for one website across 16 scenarios, I do need to do some things, right? And imagine if they're from the spectrum of a feature phone to an iPhone. Or if you test 17 ports of a router, or whatever. I'm just randomly making numbers. Test tool availability. This is another interesting thing. Sometimes what happens, like I said, is the tools are not available. The tool is either too expensive, or it's not available, or people don't know how to use it. That could also cause a reason for your ratio to vary. Quality gate criteria. This is interesting because I know he mentioned quality. Sometimes it does happen that when you have a lower ratio, you're not as stringent about your gating criteria. So I think the important lesson that I took when I looked at this spectrum is, it's not that quality is not important. Quality is only as important as how you choose to look at it, irrespective of the ratio. So if any of you did your standard PMI, right, you would have scope, time, resource, and quality in the middle. I don't know, I did it a long time back, but if it's still the same triangle, but hopefully it is. And the quality in the middle. What you do not compromise on is quality. You compromise scope, time, resources. Hopefully that's the factor that I'm giving. So yeah, we shouldn't do it because it's not important. So you are not stringent. Typically I've seen the stringency varies from stringent to medium stringency as you go about. Funding, very important. Again, this is a factor. It's not always going to be that. The thrust upon them is sometimes the stress that comes from funding. Often with zero testers, like he rightly said, it's a new thing, you don't know, you don't have clients. It's a very good example actually, in which case the funding is undefined. You really don't know, you want to see. But maybe 10 is too much, but with 2 or 3, it is often how you do greenfield stuff. You put it out there, you see where it's going. Which means, if you're an engineer in that, your responsibility is to make sure that it goes out right. It's even more important that you test. It's not less important that you test. And as a leader, your responsibility is to make sure that you put out the right thing, otherwise you're never going to get next round of funding. Whatever you do. Typically, 1:1, it's often steady funding. It's very often long T&M type of projects or a big infrastructure type of project. But be careful with those ratios. Make sure you have those ratios for the right reasons. 8:1, sometimes it's reverse. It's still under stress. So if the reason is you're highly automated and all those good reasons that I talked to you, the ratio is justified. But sometimes it is stress. It is simply a nature of the industry that on stress these ratios change. And as an engineering team, you need to be appropriately planning and appropriately making sure that not only from a people perspective, from a technology perspective, adopt DevOps, automate, make sure your people can code, all of that stuff, or make sure you can code, for example, most important. Because if I have a QA engineer who tells me that they can't code, I ask them, what did you do in engineering? You should be able to code, you're equally capable. Under stress, and the steady part is there. Job descriptions. Here's an interesting thing too. Again, sometimes you don't know what to hire for, and thus you wait. If the job descriptions are typically evolving, the ratios are typically higher or zero. If you have much steady state kind of a scenario, you do tend to see ratios higher. Again, this is just one trend here. So the ratio doesn't really mean to quality, it just depends on what you do on the product. It's a thought process, it's not a number. Expectation management support. You need to make sure managers are aware of what they need to do. Create a phase matrix in waterfall and V and all of that in an agile mode because of its fundamental way of ensuring that it's one team. I think I heard T-shaped skills and the way you try to move towards DevOps and all that, it typically can be high. Not saying it must be, it can be. It is possible to have a cross-functional team with specializations but no role descriptions. It's a tough one. Half the room here raised their hands when I asked for QA, right? And half raised their hands when I said dev. So it's a mental shift for each one of us. What I think is that this goes through is the kind of things that we talked about, like route testing, dog fooding, the engineering controls that I think the previous speaker talked about. Some of those help you adjust and manage these kind of things. So that's what I hoped I would leave you with, and hopefully you had a good conversation with each other. I can take a few questions if there are any.
A solution architect. So, how do you define the developer? Do you mean developer or including those business analysts and other supporting roles, or?
Okay. I think each person has their own definition. In the context of this presentation, to me, a developer is somebody who codes. Everybody else is support function. That's what one is to. What's your ratio of business analyst to?
For one agile team, there will be maybe one business analyst.
Maybe 1:10-ish.
Something like that.
Yeah, that's okay. That's sort of like your documentation. It's a horizontal. It's a support function.
One question.
Easily have an ability to write some sort of automation. Most of the testers in this case would have a strong Java knowledge. Maybe the way to plug it is at your interviewing stage, if you know what I mean. You hire those type of people. That's where you stop. And you train those you have. But yes, it is relevant. That's one way of moving across towards a DevOps culture, which will naturally change your ratio. Yes.
Yeah, the factors. Like, is it like through some study of your time, or like how you got that insight? Because when I try to match with my organization, pretty good. Like it's matching almost. Like we are around 1:7 ratio. So in that context, when I see, it's pretty much matching. Like I just wanted to know, like, because when I go to my organization back, I would like to share the same with them that we're doing pretty good, and as moving forward, I would like to say eventually no, and there is no concept of this ratio which used to exist, and probably we are in a better shape, and it doesn't matter to us because we are doing much better, and this is our future. Like that, probably if I want to.
Yeah. So I'll give you a serious answer.
Presentation. As a process, we give the small bucket of Thank you. Thanks a lot. Okay, guys, just to have a thing about the next presentation, we are having Mr. Monojit, who is already here. So we will set up his laptop for the...
My name is Monojit Basu. I am a founder and director of a small startup called Tech Yugadi. We do consulting on cloud and analytics, and we delve into technology. We are a little bit hands-on kind of people, so the presentation is also a little bit into technology, a little bit into coding. So hope you'll find it interesting as well. My background is actually I have around 20 years of experience in the IT sector. Worked in companies like Sun Microsystems and IBM. So I thought you could call me kind of misfit in this crowd, because I expect that most of the people here will be from QA. My role has been mostly into dev as well as somewhat into product management. So how do I fit in here? Why did I come here at all? So to answer that question, actually, one of the things that I have practiced quite effectively, and have influenced other people also to work on is test-driven development, because for me, I've always felt that quality starts from the development phase itself. And I'm happy to see that even as we move into paradigms like infrastructure as code or configuration as code, these practices, the learnings of test-driven development are being translated into those paradigms as well, which I feel is how it should be. So I want to share some of the things that this is a very this is still a green field kind of. It's not that we have understood all the things about doing test-driven development on infrastructure. But that is why it's interesting, because there's things to be learned, things to be explored, and there are challenges that can be solved on the way. So we are also learning, and we just want to share some of these learnings with you in the next half an hour or so as code, and then move into what is test-driven infrastructure. What is special about it, and then we'll take a few use cases of running test-driven development on infrastructure, which is what test-driven infrastructure is all about. And then we'll just run into some concluding remarks. So infrastructure as a code, as the previous speaker was also talking about, QA is not just about running tests. QA is also about writing code, especially more so today, because the level of automation that we are striving to achieve requires everything to be automated, not just the unit tests, but also the deployment tests that you want to run before you deploy. Okay, and I'll give some examples about it in one or two slides from here. But just think of it as any speaker would allude to in these days. We think of complexity decreases. So you're from QA. Most people are from QA, let me assume. So do you have things like a product matrix against which you are going to a big table, like you have say 5 or 6 platforms, 5 or 6 databases, and then for each of them you have about 3 or 4 versions, and your product has to be certified on all those, so that probably runs into about 100 different combinations. So that is where I started my development career from. Today, I do think it is simpler, but not all that simpler, because you may not be supporting those 100, that table with 100 combinations, but you still need to support combinations of different cloud vendors. Maybe at least 5 cloud vendors anybody has to support, including some of the private cloud vendors like OpenStack or CloudStack, because you might want to deploy that sort of environment in your own premises. Then devices, network protocols. So the complexity is still there. And the other form of complexity is about the kind of code, the kind of the size of the software that we are delivering. And that is where microservices and things like that are coming in, because it is huge. The number of lines of code is huge right now. In order to support, look at any platform, let's say Spark or Hadoop, it's huge compared to a database, right? So a database will be, even today, MySQL, it's not that big when you install it. But when you install Hadoop or Spark, it just takes so much memory, because the code is there, and you have actually not only taken your code, but you have to use other people's code, and it becomes huge, and complexity is still increasing. So to manage complexity and scale, the only way going forward, the only solution is actually going for a software factory model. So what we're calling infrastructure as code and all these things have been practiced is sort of learning from other industries like automotives, for example. They know exactly how to automate the process, and they have learned it over decades. And we are trying to practice some of this. We are trying to build software factory model. And that is where the infrastructure as code is coming up. So automation is the key to manage scale. And again, you might have heard of these, not so many of you probably, but there was a model called CMM level 5. What it means was optimized processes. And what we are coming to is optimized processes on the cloud. So automation is about optimized processes more than anything more. So this is where infrastructure as code is coming up, and of course the innovation in terms of technology we are seeing in terms of languages. If you can't call it programming languages, let's see, call them languages like Ansible or Chef and Puppet. So what is test-driven infrastructure? So test-driven infrastructure actually takes the learnings of test-driven development in the world of DevOps, structure as code. So if you don't think of just like you think of servers and your applications, your databases, and so on. The key difference, however, is that whereas the test-driven development is still about functionality, you want to test the functionality of each unit perfectly before it integrates with other units. Test-driven infrastructure is about configuration. So you have to make sure that your system is configured for operations, smooth operations, for performance, and for adaptability. Okay. Okay, I'll give a little bit of background on that in that case. Ansible, Chef and Puppet. So everybody has. Okay, so let's go back, step back a little bit. How many of you have written or coded installers of any software? Installers. Okay. So you might have. So Ansible, Chef, and Puppet are like large-scale installers for the cloud. Okay, and they allow you to set up, install not only the software, but they start from installing the machines, the platforms, the databases, the network connections, everything. And then on top of that, they configure the software. And this is done at cloud scale. Okay. So there are three languages over there. One is Ansible, one is Chef, one is Puppet, and then the other one that's also coming up is called SolStack. And it connects to the swarm of other machines on which you are setting up your cluster or your scalable environment using SSH. So you do not need any additional infrastructure. Whereas Chef and Puppet uses stuff known as agents. So you have to install an agent on each of those machines. So if you are setting up a Hadoop cluster of 20 machines, you're going to set up an agent on all those 20 machines. Whereas Ansible, you can just work with SSH on each of those 20 machines. So this is the key difference. But it's essentially an installer which installs ground up, starting from setting up the machines, platforms, databases, network connectivity, everything, firewalls, whatnot, and then configures this entire product. So think of setting up, say, an e-commerce server. That will require obviously a couple of application servers, messaging servers, right? So this kind of complexity can be managed much better with a ground-up installer, which is what Ansible provides. Now, you have written a code to set up this before the whole system stabilizes and becomes ready for prime time. So that playbook is essentially the code to do this ground-up installation. And the test framework is going to run some tests on that playbook to make sure that the infrastructure setup is going to be done right. Any guesses? You could guess, and it could be a wild guess because I didn't know until somebody told me. Yeah, you're close, pretty close. But it's a staggering number, yeah. Okay, so I'll give you the answer. It's probably one per 5 seconds. Okay, so there's about 20,000 deployments per day. Okay, that is not uncommon for all the planet scale deployments. You could substitute Amazon for Facebook, and I wouldn't be surprised if the number is very similar. Okay, so this sort of automation requires everything to be frictionless, bulletproof. Okay, so continuous deployment is one of the reasons why you need your infrastructure to be codified and tested when you're writing that infrastructure as code. Rolling upgrades, very similar. I mean, rolling upgrades are going to be less frequent than continuous deployment, but still there are going to be changes, especially if you're looking at not only the operating system platform but also the device platforms. Monitoring, disaster recovery, and security and compliance. So these are not the only use cases. You could take auto scaling, for example. You could take many other use cases. So my goal was to just introduce you to some of these concepts using some of the use cases that you need a lot more. Okay, and the reason I'm looking at it from the use cases perspective is because I have this product management background. So whenever I find this shiny object, I try to see what does it solve, and then try to map it. That's kind of a habit. And now I'll go into some code snippets to give you a little idea about how it looks like. And this is by no means complete, but it should give you the idea of how to start using these tools. Hopefully, you'll find it interesting to start using these tools when you go back from this conference. That's probably sufficient achievement for this kind of a session. So continuous deployment. Look at the right side. So there are two parts of this continuous deployment. One is to first ensure that your services have been deployed properly. And the other part is to make sure that the changes are effective now, right? Because that is where continuous deployment has to give you a proper green signal. So don't be too bothered about the code. It's kind of self-explanatory. It's not a very complicated code. So we are using server spec, and server spec actually is built on top of Ruby. Okay, so but the code looks pretty familiar to any unit testing code. So it just says the package Apache 2 is the package for your Apache web server. So it just first checks that it should be installed. So that is one level of testing. And then the second level of testing is it probably tries to read a web page and then check the status report,